Hello and welcome to the Racers HQ podcast. I'm your host Matt Murphy, and joining me on the line tonight we have our dedicated co-host Pat Mulry and my good friend Jesse Barrett. Gentlemen, how are we doing tonight?
All right.
Good evening.
Awesome. Well, guys, we've got a big show today. We're going to talk all about 3D printing and how it applies to motorsports, and I think it's going to be a cool pod, and hopefully we'll do some follow-up content. But let's get into a quick garage update. Pat, you've been doing anything this weekend?
No, I didn't. It was a little bit of garage cleanup. I changed storage spaces a couple weeks ago, so I did a little bit more of that. Okay. Transferred some parts from the shed out by the driveway to the new storage facility to make room for some stuff to move from the garage to the shed, and just waiting on some parts for Miku. So Road Atlanta's looking less and less. The end of this week, then maybe.
Well, dang. Okay. Well, we'll get them next year. I got that. So Pat traded some vehicles with me, and now I own a scooter, a 50cc scooter somehow. And I got that dang thing running. Guess what it was, Pat? Awesome. It was the fuel pump.
What?
It's a vacuum powered fuel pump that takes this little tiny puff of vacuum pressure off the crankcase to try to run a fuel pump, and it gets old and crusty. So I ordered one on Amazon. It was there next day, but then you still got to prime the heck out of that thing if it's been sitting forever, because it just cannot pull the fuel out of the fuel tank and get it to the carb. So anyway, it's a really terrible design. Yeah, the ballers swap them out for electric fuel pumps, but you need a controller for that. But anyway, so
I'm glad you figured out. Some work on that ATV that we swapped for, and got it idling at least.
Nice.
So I need to do some work on the mixture control, because I think it's still running rich, because you have to hold the choke out on it forever to get it to keep idling. But
small engine repairs.
The swap's working out for both of us. It was a scooter I didn't want to work on, an ATV you didn't want to work on. So
there you go. Yeah, perfect. And I got my K motor all buttoned up. I've been replacing the timing chain and everything. Got all that buttoned up and replaced the water pump and tensioner and the other little pulley while I'm in there, because I don't want any of that stuff ruining my day. So, yeah, get them. So things are good in the garage. But let's move on. We need to talk a whole lot about 3D printing. I've got Jesse here. Jesse is an expert. I think he's an expert. We're going to find out. But I've known Jesse all my life, and I think he's got a lot to add. And then I want to have Pat chime in as much as he wants to, because Pat's been doing a lot of 3D printing, and I know he'll have a lot of good tie-ins to the motorsports community, or motorsports application, I should say. So Jesse, let's get started. So I'm curious, it's my understanding right now you seem to know a lot about 3D printing, but how did we get, if we could briefly just talk about that journey, right? How'd you get into it? How did you expand? Where are we at now?
Well, we'll start by defining expert as the guy in the room who's messed up the most about it.
Hey, same.
In my case, I got into it through another hobby I've had a long time, and that was Dungeons and Dragons.
Okay.
I finally decided that, by God, never mind that I can't draw or paint or do anything visual, I'm going to learn how to paint minis.
Okay.
And then I started pricing minis. And just ahead of the lockdown, I ordered my first 3D printer. It was a resin unit. And I did that because one of the guys in the group already had an FDM printer, and I didn't want to duplicate.
Okay.
So I got it for printing little people and painting them. It turns out that printing them and painting them are two different hobbies.
Mm-hmm.
And unfortunately, the printing part kind of stuck. And so I expanded to the point that I've got 9 units now in various states of functional, 3 resin printers, which are what you use for minis, and 6 FDM printers, which are what you use for everything else. And from there, I've just been having a lot of fun printing.
That's awesome.
Are you farming those?
No, I buy them like everybody else.
No. I meant, are you selling your prints to have 9 printers? Typically, people run a print farm by the time they get that many printers.
No, I can't keep them all up that long.
Nice. This is very similar to the lemons racing we do. So I think we're
really.
all on this. Yeah, we've all got 9 dead things in our garage for sure.
No, you've got 9 things. Which 2 or 3 of them are working that day is the question.
Yeah.
3D printers are very, well, until recently, were very much the same.
Interesting. Okay. So they're a little finicky.
Yeah. The resin units are actually more reliable and are easier to work with. I'm glad I started that way, or I would have given up. But the flip side is there's more post-processing, and the chemicals you're handling are less friendly. Unless you're printing ABS or ASA. Those are inherently toxic and might kill you.
So yeah, you talked a little bit about the kind of printers you're using. Do you want to talk a little bit about like that range of printers, like what those different maybe types of printers? I know you just released an article that we read. I think it's posted in the chat.
Feel free to link it to wherever this is going.
Yeah, so you started mentioning a few different types of printers there, but I'm an absolute noob here, and I really need you to speak slowly. But if you could just from that standpoint, like just tell us about a few different types of printers, like your bronze, silver, gold. What's the happy medium there, and especially with the understanding of the types of stuff we're trying to make. Right, we're trying to make little tiny plastic parts for our race cars.
Well, I will start with a breakdown of what's what, since that was the article I wrote. And often the first question I get asked is, what kind of printer should I get? What kind of car should I buy? Same question. What are you going to do with it? So the most common printers are the FDM, and those are functionally a hot glue gun at the end of a robot. Several different flavors of robot can do it, but you are extruding a molten plastic in layers to form whatever it is you are trying to print. And those are the Ender series is definitive. The newer models, like the bamboo, anything where you're squirting plastic down. 3 most common varieties are the Cartesian, which are so named because you've got movement in each of the 3 axes, X, Y, and Z. And they're occasionally called a bed slinger because the bed that the print is sitting on moves back and forth. This results in a lot of mass in motion, limits your speed, and has a few other disadvantages, but they're the easiest ones to wrap your head around what it is doing. So they're not often not good printers, but often good starter printers. You can take this, you get it working the way you want it to, and you've learned way more about a 3D printer than you ever wanted to know.
Gotcha.
Next evolution from that are the Core XY, which are still in the Cartesian family, but the bed, instead of moving back and forth, is moving down a fraction of a millimeter with each layer. Whereas the print head that's squirting the plastic is, it squirts for the layer, drops down just a little bit, squirts for the next layer. These are generally considered to be the best compromise between precision and speed. You're going to get 9 times out of 10 your best quality out of a Core XY. The ones I personally like are the Delta style, and I will say that they look like something out of a bad sci-fi movie, but that's because they've been in several bad sci-fi movies. It's a cylinder with 3 arms, the bed is fixed to the bottom, and the print head is moved by the motion of the 3 arms. It has the highest potential speed of any of the standard FDM printers because you have the least amount of mass in motion and all of your motions are equal. Movement on any one arm is the same as movement on any of the other arms. So very easy to optimize for speed that makes it look like a time lapse. Downside is you start getting into what made it do that as you're trying to plot a mistake in 3 dimensions on hardware that you barely understand.
Right.
And those tend to have a more limited build volume also?
Usually, yes. Just because as the build volume increases, the height increases exponentially.
Yeah. So Matt, build volume, and for other rookie listeners, build volume is sort of, you can think of the area that you have to print, and so that's going to be constrained by, the physical limitations of the hardware, right? So
Gotcha.
often you'll think of it maybe like as a cubic foot. If your bed was on a standard like Core XY or other Cartesian printer, 12 inches by 12 inches and 12 inches high, that'd be 1 cubic foot. And that's not too far off from kind of a medium level standard 3D printer. The ones that Jesse was just talking about, because they're kind of in a cylindrical form, like they're great for printing cylindrical things, which is not always the real strength of a 3D printer that tends to be a little bit more linear. And good for building tall things, but maybe not always as well. Certainly, it hasn't been what I would be printing with for car stuff.
Gotcha.
Right.
But man, they are cool looking, and watching them is mesmerizing.
Yeah, they are hypnotic.
Mm-hmm.
And because most people don't want a printer taller than they are, there's a limit to the bed size on them that you don't have in the other design.
Yeah.
Gotcha. And then so Pat, are you in this like Core XY zone here? Is that what you're using, or like?
Yeah. So I started off, I guess it was probably 10 years ago, maybe a little bit more than that. Really, when the very first consumer grade printers were starting to be manufactured, and what had gotten us into it was my oldest daughter, who's now in graduate school, Jesse. For science fair, we were reading in Make magazine, like, hey, maybe you can build a 3D printer out of junk inkjet parts, right? And I'm like, well, that makes sense. Like, and so we tried that, and it didn't work very well. It was an ender, and we could barely get it working. And this was Murphy. This is like complete bleeding edge, like pre-alpha. I mean, it's so far out there, and I was not nearly nerdy enough, savvy enough to be able to build the boards and decode it. I mean, there just was like zero level of support for any of this other than like on Reddit or forums when we remember that those existed. And like I built my first Arduino for that and started working with that, but just it was so deep down the rabbit hole and skills that I just don't have enough of to stick with it, and we never really got it working right. And then it was okay for a science project, because science projects can also be no. The answer can also be no to a science project. And
science has found that no.
Right. Possible, yes, by someone, by us, no, and certainly not with just the parts from one dead inkjet printer. Like you could, if you had several, you could maybe swap enough together, but even then, you need more stuff. So a couple years passed by, and then I bought a Prusa 3, and that was, shortly after he came out with those. So Joseph Prusa was really big in the game at the time with the Enders. Like, he was renowned, and that's what he built his company out of. And so,
I'm sorry, can I interrupt? Are Enders
Yeah.
like a generic format, or is that
Yeah.
like a
Ender is a Chinese manufactured open source printer.
okay?
That sole saving grace is they were affordable.
Okay.
yeah.
They brought 3D printers into the reach of everybody.
But then people just kind of clone that design, or
No,
It
they
was open
cloned it.
source.
okay.
I mean, like
Gotcha.
Prusa is the one who kind of was big at the time, and it was like using all thread rod for structure and unistrut and like stuff you can go buy off the shelf at Home Depot, and then stepper motors you would have to obviously order, and the electronic components and bearings and stuff like that from specialty manufacturers. But the major hardware pieces were pretty readily found. And but like I said, no commercial support for it. So when Prusa started his company and built the 3, I bought a 3 and upgraded that pretty much all the way through the end of the 3 line. And then when he announced the XL, I got on the wait list right away because I was like that. I'd kind of outgrown what I could do with the 3, and I saw the promise of being able to do engineering grade plastics that you really couldn't do with the 3 without doing these massive upgrades to it. And so now I've got an XL in an enclosure, and it's fantastic. And we can get into that now, Matt, or we can get into it later. I don't know how this works in your agenda better.
No, you're fine. I am curious, Pat. So just back to my question, that Prusa XL, is that what you said you're running? Is that a Core XY design?
It is a Core XY design. Okay. Yeah, it's that was, I think that's the first Core XY design that Prusa did. Mm-hmm. His the 3 was a bed slinger, and then but the Core XY is it's a more stable platform. So basically, a podcast is an awful medium for describing. Essentially, what you have is the print head is moving in an XY direction, but all in the same plane. And then the bed, and it's fixed rigidly at the top of the printer, basically. I mean, rigidly in that the 2 axes are at the top of the printer, and the bed moves down with each successive layer, right? So it'll print the first layer, and the bed will go down, half a millimeter or whatever, what your layer thickness is, and it'll print the next layer, and it just repeats it in that method. Whereas on my Prusa 3 and other bed slingers, the print head is moving vertically between stages. It's moving Y front and back and X side to side. So it's a lot less. They're not as heavy typically, and because you've got all that movement, you can introduce all sorts of problems into your prints. Particularly for stuff like for the stuff that I do for the race car, like the external appearance is really secondary to function, right? But for the stuff that Jesse's doing, where you want to be able to do as little post-processing as possible on it and then paint it to use it for something else where appearance really matters, that was not a great method. That's not a great method for those. But the XY, I mean, again, that's not my priority isn't the external appearance, but they're great looking prints. I've been just super thrilled with my Prusa XL. Now it's Prusa is a premium product, right?
Gotcha.
And that was the compromise that I accepted, right? Because I know, having gone through the process with Katie and trying to build it and support it ourselves, what I realized is that is not in my skill set, and I need something where someone else has already worked out the bugs on it, that they're providing a really finished, I don't want to say idiot-proof product, but a very finished product, and then they have a level of support available for it when I run into a problem that I can't solve. Whereas there are less expensive printers that print just as well, but are not as well supported. It'll be a lot of community support or stuff like that. Community support is really hit or miss. It can be really great, or if you have if somehow you have a problem come up that few people have experienced, you may just be out there on the ledge for a while. So,
Jesse, is that kind of the range of product that you would recommend? Is there a happy medium that might be a little bit lower than
Actually,
the Prusa
there
premium?
is.
Yeah, there is.
Prusa is top of the line.
Okay.
If they mail me the lottery check by accident, I'm going to have one of their new 5-head jobs the next
Mhm.
week.
Yeah, those are sweet.
Yeah,
I
5
don't have one of
colors,
those.
5 separate print heads, gorgeous design, almost no waste changing color. And I need to sell a kidney.
Mhm.
Yeah, those multi-tool ones are really expensive. I don't have one of those.
But you can get equivalent quality to the standard Prusa line out of the Bamboo series.
Okay.
And those are going to set you back hundreds instead of thousands.
Yeah.
Gotcha. Okay. Cool.
The one I'm currently running is their mid-range unit, the P1S,
Yeah.
which is an enclosed Core XY. It's got 2 downsides in my opinion. Having come up through the open source community support, I like that.
Yeah.
Nobody can take that away from me. Bamboo is very proprietary. So far, they are only using that to increase the reliability and stability of their product. Emphasis on so far.
Right.
And the P series, the only way to access it remotely is through a cloud app. And I would much rather have it on my network at home.
And
Gotcha.
can you not hack Aquaprint onto it?
No.
Huh.
It's a closed ecosystem.
Yeah.
So it's either carry SD card back and forth or use the cloud.
Yeah.
And since I've got
Which means somebody's going to start ripping it off over in Guangzhou if it's anything of value.
potentially,
Yeah.
and but I got spoiled. I've got Octoprint on every other one of my printers. I can run the 5 that normally work from my desk at the same time.
Yeah.
While monitoring them, I deal with the cloud app because I didn't want to pay the extra $1,000 for the next level up.
Yeah.
But in return, I'm printing up through nylon without a problem. I'm looking at some of the higher end stuff that it's capable of and going, can I justify paying that for the material to see if it'll print? It took very minor upgrades to move into that next level world of materials. And I slapped a 4-color changer.
No, that's
Yes,
cool.
it produces a bucket of poop because of the way it changes color, but I can still print in 4-color.
Yeah.
Or I can load it with different materials and print this, then that, then the other in rapid sequence.
Yeah.
So you like this Bamboo line? It sounds very impressive.
They, like the Prusa, are almost a tool.
Yeah.
Not quite yet, but almost.
Interesting.
Yeah. They're very well reviewed.
Okay.
Like
cool.
if you were asking me today,
Mhm.
what should my first printer be? I don't want to, take out a line of credit for it. I would tell you that one that Jesse's got, the middle of the line Bamboo.
Okay.
Gets
cool.
great. I haven't ever used one, but it gets great reviews from people that I trust, not just Bamboo shills.
Okay. Let's put a link in the public chats there. Maybe if somebody's got a link to it.
Yeah, I'll
just so we
pull
can
it
remember
up
what
for
it
you.
is.
Okay.
I think you
And-
guys have mentioned this a few times, so I wanted to talk a little bit about those features, right? You talked a little bit about the architecture of
Right.
them. And I guess we're kind of skipping over resin printers right now, if that's okay.
They're a
But
specialty of their own. We can come back to them.
yeah. Pat, do you ever mess with the resin printers at all? Do you think that's a
No,
motorsports
I
thing
think
applicable,
they're
or-
really neat. I think they're really neat, like for the stuff that Jesse's using, for stuff that you want to be really, really high detail, fine detail at a smaller size. The resin printer is absolutely the way to go. It can do things that you can't do with an FDM printer. But for the stuff that we're thinking about using most of the time for motorsports stuff, I don't think it's worth the compromise. The stuff you can do with the FDM printer requires a lot less work. And Jesse could talk about the post processing because he's done it, but they're messy.
Yeah, gotcha. Interesting.
Like I said, we'll come
Um,
back to them. I can argue part of what you said, but no point in derailing everything at this point.
very kind
so
of
you
you.
started talking about a few other features, though. You talked about, and this is just real basic stuff, but
Mhm.
I understand temperature control is really important. So we
Right.
talked about whether or not it's enclosed, and I guess those bamboos are enclosed. Is that correct? The ones we talked about?
The P series, the base model is an open box that you
Okay.
can buy sides for. The P1S has the sides on it. And then
Yep.
the X series is also enclosed. They've got the A series, which are bed slingers of a couple of sizes,
Yeah.
and they're just sitting open.
Gotcha. And that enclosure is important not only to, I guess, control the fumes and stuff like that, but also to control
Temperature
the
stability.
temperature. Okay, and that matters because you're basically spewing like a hot liquid and letting it cool into a solid, and you want to make sure you're controlling that experience as much as possible, right?
Right. The biggest problem is at the lower level, it's draft. It does
Okay,
not take
interesting.
very much air movement to warp a print. You've got something sitting there warm and you cool part of it quickly, and it warps and pops off the plate, and you're printing spaghetti, which is
Interesting.
the technical term for spraying little bitty strings of plastic all over nothing until you notice. And if you went to bed already, you wake up to spaghetti for breakfast.
Gotcha.
Yeah. Yeah.
Does
Yeah.
that happen to you a lot, Pat?
No, it doesn't, fortunately. But but it is one of the benefits of the enclosed printer. There's some filaments are more prone to warping off the plate than
Mhm.
others, and there's other ways to help avoid that in how you manipulate your print. Um,
Mhm.
but having an enclosure is sort of the easy button for it. The
It's
tough part
step
is, I
one.
mean, yeah, Bamboo's done a great job putting theirs in an enclosure right off the bat. It makes everything a lot easier to have it enclosed, but that's something that is like the last 3 or 4 years that people have really
Hmm.
realized, like, that's
Right.
really really a big deal. It's funny, if you go and if you start doing any level of research on this, what people used to use as enclosures a lot, the cheap hack was go to IKEA and buy a lac coffee table and put that over the top of your
It
printer,
was a
and then just
perfect
put
fit.
plexiglass on the sides and hinges on one side, and that was
Mhm.
good enough. And
Nice.
cheap, easy. Yeah.
The
Nice.
lap tables are exactly the right side for the Ender 3 series and its clones.
Yep.
Nice.
The
Um,
other one that they would use is go to the garden store and get a small grow house.
Yep.
What I've got for my Ender is a Reality branded grow house.
nice. Um, Jesse, we had lunch the other day and talked about all this, but
Mhm.
one of the other mods you talked about, or features, I guess, is the temperature capabilities of like the
Right.
printer, right? And then I think we probably should talk about filaments as well. But you talked about an interesting mod where you've got kind of a sandwich of different types of materials to help, I guess, increase
Oh, right,
the
right, right.
temperature of the product you can print.
That we were talking about coming up from the base level and building it into one of the higher quality units.
Yeah,
And
yeah.
so if you start with something like an Ender or one of its clones,
Hmm.
you are normally using a print system that's basically based off a Teflon tube
Okay.
shoved all the way through the heating element. And this severely limits the temperature you can print at. It's fine for PLA for printing toys, but they're not stable outside in the summer around here, much less
Yeah.
in a car or inside of a car.
Hmm.
So PLA is fun, but not particularly useful. The exception
Except
to
I'll
that,
tell you, I was going to say one exception is for prototyping. It's great because PLA is cheap, it's
Mhm.
dimensionally stable, and when you don't, you're not going to use it. You're just using it to check fit. I mean, like, I was showing you the dash insert that I'm doing for Miku, and that's the third version of that,
Which
because
would be
it's
why
gonna.
it's white. Okay.
Yeah, yeah. The first one was neon green. The second one was blue. It was, what PLA rolls am I burning off here with this?
Mhm.
And because eventually that's going to get printed in an engineering grade plastic that, PLA you can find for 15 or $20 a roll. The engineering grade stuff is like $90 a roll.
Right.
And so you want to have that, like, you don't want it to be in, I'll get this to 90% and then I'll do a final in that. Like, you want to have it final draft stage before you go to the engineering grade stuff, because it is so expensive. You don't want to
Gotcha. That's smart.
make
That
a
makes
mistake
sense.
there.
Yeah.
And it does have a few other advantages. It's the preferred material for people who are doing lost PLA casting,
Yep.
where you print with absolute minimum internal structure, pack it in sand and pour molten metal in the top, and it'll just burn it all out. And then there's a enhanced version called PLA Plus or PLA Pro that has some of the highest strength of any of the user printable filaments. I won't mention some of what I've seen them used for, but assuming you're not in an environment where temperature is a problem, it can be amazingly useful.
Yeah. And yeah. And
Um,
and I think it's non-toxic too. Isn't PLA non-toxic material?
yeah, and it's corn.
Yeah.
I got
So there's
you.
plenty of it.
I feel like, okay, let's get back to the mod, because I want to hear about the mod, but then we should probably talk about all the different filaments.
material.
Yeah.
Well, temperature and filament go hand in hand.
Right.
So I print a lot of PETG, which is basically what a water bottle is made out of.
Yeah.
Okay.
It is a medium temperature, medium strength, very temperature tolerant, and very inexpensive material to print with. Once you figure out how to work with it, and it's like all of them, it has its quirks.
Yeah.
It's amazing stuff. A lot of what people use some of the higher end filaments for would be just fine out of PLA or out of PETG.
Gotcha.
The problem is I'm reaching the point where that Teflon tube I talked about is going to scorch.
Mm-hmm.
What kind of temperatures are we talking here?
250, give or take.
Okay.
Celsius.
And they're rated, Celsius. Everything is in Celsius and millimeters.
Gotcha.
We'll make that clear right away, just because that's what all the printers are configured for. And so, like a Teflon pan, you don't want that burning up slowly in your hands.
Yeah.
And so the first thing you talk about in one you see ref hot is what's called an all-metal hot end, which is generally a bimetallic unit where you've got a conductive material, usually copper, that's in contact with the heat block where you melt the filament, and the heat sink where you cool off so you don't melt the filament, with titanium in between because it's a lousy heat conductor and it doesn't conduct well from the copper to the titanium.
Gotcha.
And you put that in, and now you've opened up a lot more filaments because you've gone from topping out at 250 on a good day to 350, depending on the rest of your hardware. And that means you can start playing with the PETG, the ASA, and ABS. And we talked about warping. You want bad about warping. ABS is the worst.
Yeah. So just to maybe back up a little bit for listeners who are maybe a little lost with the anatomy right now, the way you think of it is your filament comes on a roll and it looks kind of like fishing line, basically, right? It's 1 3/4 millimeter
weed eater line.
Kind of fishing line, yeah. And it's coming in through through a hole in the top, and there's a motor there, a stepper motor that has a gear on it, or a hobbed screw, or any number of ways that is driving. You put the filament into that, and it grabs it like with that gear, and it's then pushing that filament through the hot end that's taking that solid filament and melting it past its glass point, basically, and then then extruding it through a nozzle that's much smaller. So, like for example, I typically use a 0.6 millimeter nozzle for my stuff. 0.4 was the standard for a long time. Now they're all over the place, but you can go anywhere from like 0.2 if you want to do really fine stuff to I don't even know what the max is on an FDM, but I use 0.6 usually. And so it's basically by jamming that with the solid end of the filament through the bottom of the hot end, it's extruding that filament through that nozzle, and the nozzle then is what's in just almost contact with the print surface. And that's where, like when you're like most of the printers now do electronic, self calibration on the bed, but it used to be on my old Prusa, the calibration for it was a manual calibration, and I would turn the lead screw by hand until the nozzle just dragged on a piece of standard 20-pound copy bond. And that was how you knew that the print head was the right distance from the plate to begin printing. Now they all do it they all do it themselves, and it's so much better.
If you're doing it manually, use Post-it notes. They are incredibly consistent.
That's a good idea.
Huh, interesting.
But that's an old timer problem now. It's like saying, if you have to crank the Model A.
Yeah.
And the E3X that still has to have the bed manually leveled periodically. So
wow.
Yeah. So that sounds like a really cool mod to help bring up that temperature.
Right.
Oh yeah.
What I'm curious, just quickly, maybe what are some other like common mods that you're doing? What are some of the maintenance items that you're having to deal with? Like, what's the care and feeding?
Well, the next obvious mod, the gearing that he just mentioned.
Mm-hmm.
If you want to print the more exotic materials, they are often more abrasive.
Okay.
So you upgrade from whatever soft material your PLA is slowly etching to a hardened steel that something like a carbon fiber impregnated nylon is not going to wear away in the first 20 feet.
Gotcha. And is that bamboo coming with these features, or is this something?
No, but it's an easy swap. It's 5 minutes to change them out.
It's the KN air filter of the 3D printing world.
Okay,
Right.
Gotcha.
Yeah, they give
5
you
more horsepower, bro.
That's right, 100% all day long. Dyno tested.
Yeah, they give you the cheap one and charge $30 for the replacement.
Yeah. The next one I bet Jesse was gonna say is a hardened steel nozzle. So most of the nozzles that come on the printers are typically brass.
Okay.
And that's fine for anything like your standard PLA, your ASA, your ABS, your PET-G, so long as they're not fiber infused. But if you start having the carbon fiber stuff, so like I've printed a lot over the years, a lot of carbon fiber PET-G because it's a really good compromise, and for stuff that we use it for.
Beautiful.
Yeah. Like the gauge pods in Miku on the center console, those are all in carbon fiber PET-G.
Gotcha.
But that will wear out a brass nozzle really, really fast, and then you start losing your dimensional stability on your prints. So you just get a hardened steel nozzle. They're easy to change out, and then they last just forever with those. And then that's especially true for any of the engineering grade plastics that are going to be much harder and higher temp, because obviously brass gets softer at a lot lower temperature than tool steel does, for example.
Well, and the harder the material, the more the brass is going to wear away as it goes by.
Yeah.
The other reason to change it out is if you do a lot of printing with glow-in-the-dark materials, which are just fun but also very abrasive.
Really?
Gotcha.
I didn't know that.
Yes. Oh, you can eat a brass nozzle in about a roll of glow-in-the-dark.
I guess
little
it's from
chunks
whatever
of uranium in it or something. Or?
Yeah.
No, it's got little chunks of stuff in them.
Yeah, sure.
And yeah, it eats nozzles.
Interesting.
Flip side to that is the brass ones are cheap. You just change it out when you're done.
Yeah.
So what kind of maintenance are we doing on these things, guys? Like, is it 100,000 mile tune-ups and stuff like that, or are they just kind of run?
At the higher level, when you've got a good, reliable unit, no.
Yeah. Okay. Cool.
You blow the dust off, you lube the screws, you check the belts.
Gotcha.
That's most of the physical maintenance until it gives you a specific problem.
Yeah.
Okay.
With the cheaper units, you're checking everything every second print.
Okay. Lots of calibration, lots of check.
Yeah, they just don't hold. It's like anything that you want to be precise.
Mhm.
If it's cheap, it's not going to hold its tolerances.
Gotcha. That makes sense.
I mean, that's why it's cheap, right? It's because you're building it to low tolerances, and so it can't hold them. And that's really, one of the major reasons I went with the Prusas from the start. Was I just knew, like, after my experience with that first one, I was like, I want to go and print something, and I want it to print, and I don't want to spend 3 days troubleshooting why it's not printing, because I don't enjoy that process. It just frustrates the hell out of me. And then I want to break it, and that's not the point. This is a tool. It's not it's a very useful tool for me. I enjoy using it, but it is the outcome that I want. It's not the process that I want to be involved in.
Yeah. So we're running a little bit out of time here, so I want to move on to projects if we can. Pat, to kind of loop this into motorsports, I want to hear about a few projects. Earlier, you were showing us some dashboard components there that you're prototyping. Along with that, I kind of want to talk about what filaments, like what products you're using to print these things in. You talked about prototyping them and the lower price stuff. And then after that, I want to get to Jesse and hear about a few of his projects. But yeah, just hit us with some ideas there. How are we going to apply this to motorsports?
Sure. So until fairly recently, there were not consumer grade printers that were readily able to print engineering grade plastics. And by engineering grade plastics, I mean stuff. For example, like the intake manifold on every car that can be bought these days is made from plastic somewhere, right? You open up a hood of your new car, it's got a plastic intake manifold, and hell, that's been true for 30 years, right?
Mhm.
Well, that 3D printers weren't able to print until recently filaments that could withstand those kind of heat and fluid conditions, right? Hot oil, hot air, hot gasoline, all that kind of crap. Now they can. That's one of the things I like about my XL is the big reason for that is you've got to have a printer that can get hot enough to melt those, because they don't melt until you get to like 270 or 280 degrees Celsius, which is why they're good under the hood, because it's not going to get to 280 degrees Celsius under the hood until you don't care what happens under the hood anymore, because you're just trying to get out of your burning on fire car. But now you can do that if you have a printer that's capable of that, and so it's going to have an enclosure. It's going to have to get hot enough. But for a long time, what I was using it for was either prototyping stuff that then I could like send off to Send Cut Send, or try to figure out how we were going to make it in some other way, or for non-structural stuff like gauge pods. On a custom, when you want to do a custom dash and you don't want to pay, some jerk $400 for the thing, you can do it yourself. And, there's just all sorts of printed parts all over that car. I couldn't even tell you where all anymore, because it's just the thing that it did for me when I really got involved in doing 3D printing. And so for me, it went hand in hand with doing the 3D printing and then doing digital design for the parts. Was my mind just opened up on seeing solutions to problems that were not off the shelf solutions, right? And so it was really a shift in mentality about what you could do with the car and with things when problems came up, or you had new solutions that presented themselves. So that's two things. One, I use a design software called Fusion 360 that's produced by Autodesk. They have a free a free level membership for hobbyists. It's constrained. And then there's an annual. I'm actually on like the I don't even know what you call it, like Hobbyist Plus. Like I pay an annual subscription of probably $500, which kills me to do it. But it's such a useful piece of software that I pay it without really too much fuss, right? Because
premium CAD software, and if you want the best, you pay for it. That one is the best.
And it's great, and it's universal, and you'll see lots of people use it, and so it's easy. It's another thing it's easy to get support on. There's like 15,000 YouTube channels that have Fusion tutorials. So if I ever have a question about how can I do something that I want to do, I can go on YouTube. I can find something, it'll explain how to design it. I can change my design, and it's great. It's if you haven't used design software, start off by watching videos, because it's easy to get yourself into bad habits with something that works, but then is not really the best way to be designing things. And so you can. So there's lots of ways you can then get what is in your head onto the screen. There's scanners, laser scanners. There's plenty of those. You can use a technology called photogrammetry, where you're taking lots of pictures. And
for the listeners, Jesse's poo-pooing all these ideas.
Yeah, there's pluses and minuses to all these, but I'm just putting them out there as options, right? Photogrammetry, where you're taking lots and lots of pictures, and then the computer stitches it together and creates a thing out of it. What I tend to do a lot of times in Fusion, there's a feature called Canvas. And so I'll take a picture of the thing, so it's a 2D photograph of the thing with a ruler in the picture. And so then I'll take, and you try to do it so your camera is as planar to the surface that you want to model as possible. And a ruler, and then you can import that picture into Fusion, and you calibrate the canvas. And so now you've got a 1-to-1 size thing that you can trace in Fusion to create the actual model that you want.
Gotcha.
And then there's also lots of resources online where you can download models for free, or you can pay for models as well. So there's a very well-known, probably maybe not the first, but maybe the most first well-known site for sharing models is called Thingiverse. And they may actually be owned by Autodesk now. I'm not sure. They're owned by somebody big. And so there's all sorts of stuff you can find on there, from toys to practical things and everything in between, right?
So like Halloween decorations?
100%.
Okay, because that's how I'm going to sell it to my wife.
Oh yeah, Halloween decorations, Christmas decorations, every decoration you want. They're so Matt, get her just looking at Thingiverse and typing in things she's interested in.
I like this idea.
And it's sold. It's sold. Okay. I've started using a site looking at, I don't remember where I learned about this, called Cults 3D. And Cults, I think Cults has been around for a while, but I haven't been involved in it, but it has a lot of auto parts on it. In fact, that dash insert that I was showing you for the BMW before we started, that started from a Cults model, because I was having a hard time getting some of the compound curves to model correctly. And so I was able to take one of theirs and then make modifications from that. And I think, and there's a wide range of prices for the stuff you buy on Cults. Some of it is download for free. Some of it's $1. I think the most I've spent on one is maybe $7. For something that, again, it was stuff that it was like, well, I think it might have been this. So I'm holding in my hand, it's a no longer available BMW part, and this is a intake duct for the front bumper for brake ducting, right? So you know how like you've got on the BMWs, you've got the fog lights on the outside, and then there's like a hole right next to that, right? Well, this is what attaches to the back of that. And I just bought the model off of Cults 3D and then printed this one in, I think this is in CFPETG, to model it. And so I'll take the bumper off of the car and make sure that it fits. And then if it does, I'll wind up printing this either in ASA, because ASA is pretty UV stable, or in probably PC plastic, because that's
Okay.
pretty high durability for this use. So it's the thing. I mean, really, the thing that I like about it the most, other than like when I have a problem that comes up, I'm not spending hours searching for how somebody else has solved this. I'm spending minutes to hours modeling something and then printing it and testing it. And then I've got a thing that actually works without having to, wait for, days or weeks for a part to show up that maybe will or won't work.
Yeah, I feel like I would really enjoy that compared to like just making brackets with aluminum and stuff. It's so
yeah,
annoying. Yeah.
100%. So here's another example. The on the on the on our BMW, well, right now it's just coroplast, but there's like a plenum that actually goes above the radiator that then has a duct to send air to the alternator, right? And on our BMWs, that thing's always been busted the day that we got it. We've never replaced it, right? Well, there's that duct it's a very strange shape because coming out of the plenum, it's like this weird irregular trapezoid. And then it morphs into an ellipse. And then the BMW factory hose is elliptical on one end and round on the end that goes into the alternator. And that's how it directs cool air to the alternator.
Mhm.
Well, that transition piece that goes from the trapezoid to the ellipsoid, it's NLA from BMW. If you go out and you buy one, it's $70 or $80 from somebody else that's 3D printing these, by the way. I found the model on Cults. I think I bought it for £3 and I printed it in PC. I printed it in probably PLA to start to make sure I had it fitting right, and then printed it in PC. And now we're going to have one, and then I printed an adapter to go from that ellipsoid side to make it a 3-inch round hose, and an adapter for the alternator side, because it's like 60 millimeters, that needs to be 75 or something like that. So we can just use standard 3-inch brake hose
Nice.
to duct that from the front of the car to the alternator.
Nice.
I don't know we've roasted alternators in the past. I don't know if that's why, but the cost to do it now, despite, like if you're trying, I think there is a business case for 3D printing for people that do it for a living. That's not what I'm doing it for. I couldn't make a business case for the amount of money that I have in my printer and stuff for these things that I'm printing. But I like the fact that I spent £3 and on the model and maybe $1.50 on the expensive filament for this part instead of spending $80 on it buying it from somebody else.
There you go. Helping pay for it. I like it.
Yeah.
Jesse, what kind of projects? You sound like you're more on the. You told me earlier you were more on the hardware side, but what kind of projects are you enjoying? What kind of stuff do you like to make? What are some favorite kind of projects there?
Tying back into what that was just saying, the idea, once it finally clicks, that I've got an in-home manufacturing unit sitting right here.
100%.
If I need something, I can print it. The most recent thing I printed was the flat upholstery adapter for my vacuum cleaner, because I don't know where the old one was. I needed one, and it's like, well, I can order it. Why am I ordering a near universal plastic part? Where are my calipers? Resize that and go.
Right.
I print, because I don't own most of the designs that I print. I'm not much of a designer. I won't embarrass myself by saying what software I use as a little bit of 3D custom work. Microsoft 3D,
like the STL editor?
Yeah, 3D Builder.
Nice.
It's absolutely shape oriented. It does not manage the vertices correctly. It does not produce well-defined models. But I don't think in CAD. Gotcha. So for a little bit of mod work and a little bit of custom work I do, it's fine. If I need more, I've put up with jumping through the hoops to get and continue to update the free version of Fusion. but I
Oh,
don't need it very often.
Is that a pain?
Oh, they don't like to admit it exists at all anymore. And you have to re-update it. You have to update it every year to maintain the free license.
Right.
And they always try to sell you something first. And it's like, I don't use it often enough to justify it. No, I'm not going to give you $500.
Yeah.
I need it for this job, and then I'm done with it for a while.
And that's how I got caught into whatever the license that I'm paying for now is. I was in the middle of an arbitration or a trial or something like that when my subscription ran out, and I was like, "Hey, can I get back in that?" And they're like, "Get back into what, sir? I don't know what you're talking about." And I'm like, "Fine, just take my money, you jerks." But I do use it all the time. So,
well, and it has the advantage that if you come up with a design, you can sell yours.
Yeah, that's true.
If you make it on the free version, it's tagged, and they've got lawyers who will come find you.
Really, I didn't know that. I'm not surprised about the lawyers part because lawyers are jerks, but I didn't know that they were tagged like that.
Oh no, it's in the metadata in the file.
Huh,
it tags it as a free version, or it tags it with a code that they can trace back to you on a commercial version.
Interesting.
And yeah, they've got attack lawyers if they choose to use them. But I do a lot of fidgets. I do a lot of stuff I can give away because I enjoy working with the printers to work with the printers.
Yeah.
So, I will often show up at a writers convention and have a bag of stuff to give to people for fun.
It's not showing up very well, but it's like
right.
But it's like it's like he has all these cool little like chain things and
cool.
fidget toys,
Yeah.
Like you had the alien.
Yes.
Alien. What is it? And,
that one is the chest burster, and it's about.
It's about, I don't know, 8 inches long.
Oh no, it's closer to 14 inches long.
And it's all like a chain. The whole tail's a chain. Yeah.
And stuff like that for fun. Yeah. I'm looking around. I've got an octopus. I've got stuff holding my UV glue stuff up. I've got a goose with magnets in its bill I can hang screwdrivers from.
Yeah.
I've got a larger one that maxed out my printer that actually, I think the biggest we ever got it to hold was a 22 pistol without the mag in it. The idea was to take that whole Curious Goose meme where you've got the goose with a knife.
Okay.
One step further. I used enough rare earth magnets that mine didn't have to just hold a knife.
Nice.
That's funny.
That was the sole reason that one exists.
Yeah, and so that's really funny, Jesse, because like you and I couldn't be more different in what we use our printers for. Like I'm looking around to see what I've got, and it's like that brake duct. It's this. This is a cover. That brake piston spreader we have, Matt, with the trigger, like the trigger handle. This is a pad for that, so it fits the brake pad better.
Okay. Nice.
Yeah, like. Yeah,
Can you print? Can you print? Kind of rubberized stuff, or is it all going to be more hard plastic?
Different material.
Yeah.
And that's actually a good tie-in to one of the reasons that I believe that resin has more potential than people give it credit for. Most of the rubber material that we use in FDM printing is TPU.
Yeah.
Of various kinds. In fact, I've currently got a TPU octopus about that big. I need to go get off my build.
Like the classic for that, Matt, is like a phone case out of TPU.
Yeah. Right. Okay, cool. So you can print that. That's cool.
Yeah.
There are more flexible and a wider variety of resins available to do that job.
That's interesting. Okay.
So you can do it out of a more... Oh, when you get into the industrial resins, you've got hundreds where you've got tens in FDM.
Oh, yeah, one of those. So, what? So is that a different? Sorry, I'm confused. Is that a different printer than the bamboo that we were talking about?
Right.
That's kind of the entry level printer you were talking about.
Well, the bamboo is the. It's not entry level. It's baseline premium.
Oh,
Yeah,
okay.
so Jesse, explain how a resin printer works, because it's a fundamentally different mechanism.
Yes.
Oh, the resin printer. Yes.
Right.
I got you.
Yeah.
Okay.
Okay, so an FDM printer is a hot glue gun on the end of a robot.
Right.
A resin printer is a flashlight and a phone screen.
Okay.
You shine a UV flashlight through a screen identical to the ones used in cell phones that blats out where you don't want the light to hit. Where it does hit, it takes a UV reactive resin and turns it from mostly liquid to mostly solid.
Gotcha.
And then instead of doing
And it's shining it down like basically into a bath, right?
up through the bottom of the
okay.
bath.
Okay.
So you're coming from the bottom up. That's why they lift out of the goop.
Okay.
So you're going light at the bottom, through the phone screen, through a sheet of glass, through a sheet of very thin plastic at the bottom of a tray of goop.
Okay.
And then it lifts up and rips that layer off the goop or layer of plastic off and allows goop in and lowers back down to, instead of 0.2 millimeters, 0.05 millimeter
Oh, wow.
from where you were last time. So we're talking an order of magnitude higher detail level.
Gotcha.
Yeah.
And you repeat as it slowly rises out of the goop. You then take it, you wash it in alcohol, you remove your supports, you expose it to UV light, because in its raw form, it's kind of like ceramic greenware. It only looks like it's done. It's not. You do the final cure, and now you've got your D&D figure or whatever you were printing.
Gotcha.
This work, if I want to print metal parts in my house, I can buy a bottle and put it in my printer. I can't do the post-processing. I've got to mail it off to somebody else to have it burned out and centered.
Yeah.
But I can produce my own parts. If I want to print ceramic, and this is industrial grade ceramic,
Yeah.
I can do that and then go see my cousin and borrow the kiln. And I can have a ceramic piece that I printed. And I could print a snow angel, or I could print precision herringbone gears, which were a royal pain to produce. If I need something rubberized, I can print it out of TPU, or I can print it out of 3 or 4, I was helping a buddy of mine look, 3 or 4 different industrial resins that are, I mean, the softest one we looked at was like grabbing a hold of one of those old squish toys as a kid that had a membrane full of stuff, only it was theoretically solid. The RC guys love some of these for tires.
Interesting.
And these days, they're more likely to use resin than TPU if they know how to work with the resin printers.
Yeah.
So you've got a smaller build volume. There are now larger ones available. And you've got much more detailed post-processing. But there's enough variety of industrial resins available that don't write it off as not useful. Not anymore.
Yeah.
Okay.
That's really interesting.
There's a guy called Integza on YouTube who is trying to kill himself with 3D printers, but that's secondary. He was printing rocket nozzles, and he was where I learned about the ceramics. What I realized that he didn't is this ceramic nozzle that he printed. It prints out its resin in a polymer matrix.
Yeah.
And when you fire it, you burn out the matrix.
Right.
So you're left with the ceramic. He didn't realize you weren't left with solid ceramic. And so he starts pumping hydrogen through ceramic honeycomb, which worked really well right up until the fuel air mix outside his nozzle got wrecked.
Yep.
But anyway.
Yeah, Matt, there's if you want to, 3D printing can be a total rabbit hole.
Oh, sure. Yeah.
YouTube, certainly. I mean, like anything on YouTube. But I was watching a video the other day about about metal sintering, about printing metals, and Mark Forged makes this really, really awesome, super expensive 3D printer that it has something like 720,000 nozzles on it or something like that. And it's the way it works is it's got a bed of this center of this material, and it like lasers it, and then it sweeps it. Like this is all robotic, right? It sweeps it with another layer, and then it comes in and does the next one, and it's this set of processes back and forth until you have a part that is. So like I think some of the stuff that some of these were actually gun parts. Like these are going to be parts that see real pressure and real stress, right?
Mm-hmm.
And then on those on the sintered metal parts, and we're seeing these used commercially in automobiles now too, for what it's worth. This isn't a fringe method anymore. And you have to design them 20% larger than than your final material is going to be, because then it comes out and then it has to go into an autoclave and be heated very hot for what Jesse was talking about, to burn out the binder basically and make it into a solid metal part then. And then sometimes there can be additional post sintering processing that needs to be done if you need a really fine surface grade, for example, or super precision diameter or something like that. You may need to do some additional post processing, but it is what they're doing with this, like I remember when I was at PRI, I think it was 8 years ago, and saw some of these printers there, and they were not like, one of them was talking about how Ford was using it for prototyping parts. Mm-hmm. And it wasn't then at the stage where they could use it for production. And OEMs are using it, and OEM manufacturers are using these for parts that are more economical to do that way, because they don't need 150,000 of them, where it pays off to have a huge tool and a press or metal injection molding or something like that. They only need 8,000 of them, and this is a more efficient process for a relatively short run for something like that. It's fascinating.
Yeah, I heard somewhere, and I keep meaning to go back and double check to confirm it, but I'd heard that Porsche was in the process of digitizing a large amount of their old parts catalog.
Yeah,
so that you could literally call them up and order new parts for your 1962 whatever.
Yeah.
And they would center it and ship it.
Yeah, that doesn't surprise me at all, Jesse. I hadn't read that, but Porsche has always prided itself on, you can always come back to us for every part that you need for your Porsche. We will have it for you forever.
Yeah, and with these, as you said, they don't have to keep any stock on hand.
Yeah.
They just say, okay, we'll have that shipped to you in 2 weeks.
We are getting off in the weeds a little bit here, but and I'm usually not the one I'm not the one pulling us back. I'm always the one pulling us into the weeds more typically, but Jay Leno has gotten really into 3D printing in his garage, and so a lot of our listeners may be familiar with that because of his bizarro collection of cars that he has that he wants to keep running. And his guy, there are things out there that there were barely parts for when they were new, let alone 100 years later for some runabout. And so he's got guys working for him now doing duplication of these parts for a 1908 runabout or something like that, because otherwise it's like, this is just, it can't work.
Right. That makes total sense.
Well, and you can get into one of the baseline metal processing systems for $200,000.
Oh,
and for Leno, that's not a problem.
Right. Oh, yeah.
Sure. Yeah. Yeah.
It's the size of a closet and has the actual production volume about the size of his and my printer.
Yeah.
But it's still printing metal car parts.
Yeah.
Yeah. I mean, Mark Forged makes some smaller units, like desktop-sized units that would produce metal centered parts. Now, you still have to go through the post-processing phase.
Right.
But as a result of that, sort of like send, cut, send, there are now facilities that you can send those things off to. I mean, this one that I was watching, they'll do single parts. They'll just, you just put it in with somebody else's part run when you're doing it, and they'll do a single part for you. And obviously, a single part's always more expensive than, multiples. But that's something that didn't exist, 5 years ago.
Pat, you're bringing up some good points here, and I'm curious, little pivot. So, do they have really cool 3D printers at your makerspace that you've got in Dallas?
The makerspace in Dallas. Now, to be honest, I haven't been over the 3D printer area in at least 6 months. They had always been. I don't even remember what brand they were using. They had gotten support from somebody who donated, I don't know, 6 or 8 printers, and those were all ABS only printers, just to make the support of them easier, because things do get more complicated when you're switching filaments, from filament to filament. And it's not a problem when it's your printer, right? I mean, you know what you're doing, but when it's a shared resource, things get more complicated. And I don't know if they still have those. I know they still have them, and they have some other printers. I'm not exactly sure. It wouldn't surprise me if they've switched them all to bamboos at this point. I mean, that's a really popular, well-supported printer.
Cool. Jesse, do we have a makerspace in Oklahoma City that you're aware of, or anything like that?
I have not actually checked.
Okay.
I'm one of those people who just will get into something and decide I'm going to do it.
Yeah,
and then
you do.
I'm going to do it.
It looks like there's a couple of them, Matt. There's one called Collab OK.
Okay.
It says it's above all else a community center. I'm just looking up the headlines on Google. There's one called Prototech OKC.
What is this magic, Pat Moore?
Yeah.
You just Googled my problem. Well, thank you.
Yeah. There's a makerspace at OU, of course, but that's probably limited to students.
Okay. I'll check that out.
Oh, and in answer to your earlier question, Utilimaker is the one who bought Thingiverse.
Oh, that's right. Yeah.
Okay.
That's another big company, big printer maker company. There's lots of them.
Utilimaker is commercial industrial, but they also produce the leading slicer for home printers. Slicer is the program you use, in this case FDM, to take that graphic that Pat made and turn it into little bitty layers that you can feed out of your printer.
Yeah, we should explain that for any newbie that is sticking around. We should have explained that earlier. So the slicer is a critical piece of software. You're going to take your model, your digital model, and you're going to bring it into your slicer, and it's going to output a program that's in what's called G-code. And G-code is the universal language of printers and CNC machines. They all use G-code as well. And what it's doing is it's telling the machine how to move from here to there at what rate and in what direction on all of them. Yeah, and at what temperature, and on all of the things that it can do. So what temperature your hot end's going to be at, the rate that it's going to feed the plastic through the hot end, the rate it's moving in X and Y, and then when on a Core XY printer like mine, when to move the Z and how much to move the Z. It's controlling all of that. So and it's called slicer because it's like it takes your thing and it slices it into horizontal layers, however thick you tell it to. So on mine, typically I tend to do on most of our structural stuff, the layers tend to be either somewhere between 0.25 millimeters and 0.32 millimeters high. The taller the layer, the faster it's going to print, but the lower the detail, right? If you were doing like Jesse was saying with the resin printer, the layer heights are very, very small, which is how you get very fine detail.
Gotcha.
You aren't going to get that level of fine detail on my printer, certainly not at like 0.32. But for a brake duct, I don't need a great level of detail. None of the features on it are very small or fine.
Yeah.
They would just bust off.
Gotcha.
So yeah,
Right.
slicers are important, and if you buy a printer, it's going to come with with slicer software.
Gotcha.
Or recommend it. There are the one right now that's big in the hobby is the spin-off of Bamboo, Orca,
Orca. Okay.
Oh yeah, I've heard of
which
that.
is they left Prusa Slicer and Bamboo Slicer alone in a dark room for a while, and out came Orca Slicer. But it's, other than the fact it doesn't like my PC, it's got some amazing properties. If it'll run correctly for you, it's great.
Yeah.
But it's open source user developed, so if it likes you, cool. If it doesn't, use something else.
Gotcha.
Yeah, and I've always just used Prusa Slicer because it comes with my machine and it works great.
Try Orca if you're ever in the mood to branch out a little bit.
Yeah.
Like I said, as a slicer, I love it.
Yeah.
It just has some quirks due to my PC architecture. Built that too, probably my fault.
And it speaks primarily in whale. Is that correct?
Yes.
Oh, instead of G code, which happens to be the set of values that I live by.
There you go. Yeah, you'll want to watch Finding Nemo.
That's what happens if you got that G money. You have to live by the G code.
Yeah.
I
guys,
am a dad.
we're running a little long here. I think we need to wrap, but we do want to have a follow-up probably. Is that okay with you, Pat? Sorry, you look disappointed.
No. I think you're right. I mean, Craig gets cranky if we get more than an hour. So
yeah. But I do have a few kind of things to wrap this up. Jesse, do you have any shout outs, for our hundred of billions of listeners? You want to plug your writing career or anything like that, or say thanks to any of these communities?
Start by steering a little bit of traffic to my Substack. Saying if you think you want a 3D printer, I've got a little essay out there that covers the very basics, so you can figure out what your excuse is and probably at least decide on the right style of printer before you go any further.
Gotcha.
And if you're there and happen to be into science fiction and fantasy short stories, stick around. That's the other thing I do on the side.
Nice. Well, yeah, we'll put a link to that in the show notes, and I promoted it on our Facebook page already. So thanks for that. I'm curious, where is, we talked about Thingiverse, but as we're kind of shouting things out and other resources out there,
sure.
Where are some places that a noob could go to learn about things? Are there forums or Facebook groups, Discord, anything like that?
Yes to all of the above.
Yeah. Where do we start though?
YouTube
stuff. YouTube.
Yeah, go to YouTube and search for 3D printers. There's a lot of them out there. There's a guy who I think I started watching.
Teaching Tech.
Yeah. Say that again.
Teaching Tech.
Teaching Tech? Is that it?
That is the Bible for anybody getting into 3D printing.
Okay.
He will teach you how to set up and calibrate your printer correctly.
Mm-hmm.
And you then go from there on.
Gotcha.
Yeah. I've watched a lot of, there's a guy whose channel is called Maker's Muse. He was
Also
into it
good.
very, very early. And I think he got into it primarily because he's an RC car devotee. And so, if you're doing RC cars or drones, you're busting stuff up all the time. And so then you can, and so now I think the last video of his I watched a couple weeks ago was he's doing like mini battle bots. And so he was talking about how to manipulate slicers so that parts of your print are thicker than other parts, because you want them thicker, like a thicker shell in the place that's going to like run into the wall or catch a blade or something than the parts that maybe aren't. And they've got, I guess in that competition, they've got a really strict weight requirement. You can only weigh so many grams or something like that, right?
Weight.
Yeah. There's a guy called 3D Printing Nerd, and he lives up to that title all the way. But he has interesting stuff. But if you start printing, if you go down, like, you'll find anything on there. There's lots of videos on comparing different filaments and strengths of filaments and testing strength of filaments, because big surprise, there's lots of filament makers out there making claims that maybe, their body's writing, what is it? Writing checks that the body can't cash.
Okay.
I got that quote wrong, but you know what I'm talking about, right?
You mean the manufacturer's specs might be invented?
Yeah. Yeah. And so, and that, so like when I was looking into, the more expensive stuff to be able to use like under hood, like I want to know what really is going to hold up here and what isn't. Right. And, I forget what his channel is. He's German and he tests out new
Yes.
filaments and, like very repeatable, very honest. I've followed him for a long time. He's really good. So
His early tests were definitive.
yeah, absolutely. So there's just lots and lots of resources on YouTube for that. And
So you start with my essay. You figure out what direction you're
that's right.
Gotcha.
and then you go to YouTube.
Gotcha. I like this. Real quick, there's so much stuff to talk about, but I do want to make sure we're being safe. What is that? What is that line you cross on filaments when you got to start venting the place or?
Okay. I have a real problem with anything with styrene.
Okay.
I spent the early part of my life with heavy exposure. I know what happens when that stuff gets hot. ASA and ABS, the S is styrene.
Gotcha.
I know people who have nearly killed themselves by not venting their printer and printing a lot of it.
Gotcha.
So, in theory, a separate enclosure, not just the printer box. Let everything cool when you're done, and you're not exposed much. But those are releasing a known carcinogen and toxic compound.
Yeah.
Okay.
Some of the other higher end stuff, nylon smells funky, but unless your heating is out of control, actually isn't doing you any appreciable harm. PETG is harmless, PLA is harmless. Resin's a different discussion we do not have time to get into. Check the MSDS on the material.
Yeah.
If the filament maker is not telling you, look it up.
Yep.
Find out how toxic this gets when it gets hot.
One good thing about nylons for our motorsports purposes is that they are not impacted by gasoline.
Interesting.
Or by alcohol, right? Okay. So you can use them in that application, and now
flexible, tolerant.
Yeah, and now that we've got, I'm not saying I'm going to build a fuel rail out of it, right? But if you had stuff that you thought was going to be exposed to it, there are some plastics, that do not handle, petroleum products well at all, especially, hotter ones. But nylon doesn't have any problem with it at all.
Gotcha.
Yeah.
No, makes sense.
There's a reason that stuff is darn near universal as an industrial plastic.
Makes sense. All right. Back to the wrapping up the show, I promise. Jesse, we have a part of this show where we want to know a little bit more about you. Do you have a hype song, like when you're about to go face a challenge or maybe write a book or something like that? Do you have a favorite song you go to just to kind of get yourself pumped up?
That actually variable by
Okay.
what I'm working on.
Yeah.
I have found that my muse is music driven. So half the fun of quote fun of me getting set up to do a new story or something different is finding out what playlist I have to have going to make this work.
Okay, so you just try to dial it in.
Yeah.
Right.
Whatever I'm listening to has to match in the warped mess of mud I call a brain.
Okay.
What I'm writing. So current story, I've been listening to a lot of Space Truckin' by Deep Purple.
All right. I like it.
Matt, I have an edition here. It's a third-hand edition, but avid listener Dave Mulvey suggests that the song, he didn't suggest this, but it's from something else he sent me. I think he would agree. He'll let us know if he doesn't. That Daft Punk's Technologic would fit in on the hype list for this topic.
Okay. Nice. I like that. We're getting some some feedback from the users there. I like this. So check out those tracks. I got another one, another listener favorite, JT Toon, who always listens to our episodes, who we need to have back on soon. He was telling me the other day his favorite hype music is Paul Van Dyke, which is a 90s EDM artist. But he was just telling me how much he loved that guy. I guess JT is an old school EDM DJ from Dallas, so had to toss that in there. So big shout out to JT, who just won the Spec Miata championship up at the Hallett's Thomas Series. So big shout out to JT. All right, well, thank you for the hype song inspiration. This is good. I think we're wrapping it up. Pat, do you have anything you want to shout out to? Any other resources you want to mention before we wrap this?
Well, I was thinking earlier today that this is probably our last pod before Thanksgiving.
Okay.
And so I have thanks to give. I'm very thankful for, of course, my wife and my family, and I'm super thankful every day for you all, my race team, and for the fun that we have, even sometimes when it's not so much fun, we're still having fun.
Yeah. Sometimes we just text each other about having fun.
That's right. Sometimes we're at least still having an experience. And I was thinking last night, I guess I was thinking, it's been 15 years, more than 15 years that I've been doing lemons. My first race was in early 2009. And just what I never would have imagined the impact that it's had on my life from a harebrained scheme, number of harebrained schemes. Jay and his folks had a harebrained scheme, and then I had a harebrained scheme to jump on board that train, and I'm so glad I did. And met you and all of our teammates and so many people, and had great experiences and memorable experiences, even if they weren't great experiences.
Yeah.
And so I'm just thankful for you guys and Lemons and all that, and of course for 3D printing.
Well, sure, yeah, of course, 3D printing. Well, thanks, Pat. Well, I appreciate you a lot as well, and all of our friends we've made along the way. And Jesse, I appreciate you, Jesse. I really appreciate you coming on the pod tonight. Here's where I think this is going. I'm going to go buy one of these things. I think Alyssa's in. I sent her a link to Thingiverse while we were chatting, and she said, "You got to make me a bat." So,
do you have a Micro Center in OKC?
Well, I don't know. I don't think so. No.
You'd have to come down to see you.
Oh, okay, I didn't know if they're up there. Micro Center stocks the bamboo printer. I bet you can find. I bet you can find one local. I mean, if not, Amazon can have one to you the next day, of course. But
sure.
If you're going to order it, go through them directly. They provide better support when they know you bought it.
Okay, cool. I'll try that. I like it. Well, let's wrap this thing up. A big shout out to our F1 watch party coming up this Saturday at Sost. We'll try to have this published by then. I'll tell you, my biggest mistake on this watch party is that I made it a Facebook event. I should have made it a more ubiquitous, shareable solution. So next year it's going to go out on Eventbrite or something, and we'll just share links across the various channels. But yeah, come check us out at Sost in Paseo from about 10 p.m. to 2 a.m. We're going to watch the Vegas F1 race. But aside from that, check out Racers HQ, like and subscribe, rate and review. Check us out on YouTube or Apple Podcasts, anything like that. And we will see you at the track. Bye, everybody.
Au revoir.